Standard index form involves splitting up a number into a whole part and a decimal part, and expressing the number as a power of 10, such that there is only one digit to the left of the decimal point. When expressing a number in standard index form, the whole part of the number must consist of only a single digit, and the rest of the digits are written to the right of the decimal point. To get a decimal number into standard index form, we need to multiply or divide the decimal number by a power of 10. Whenever multiplying decimals by a power of 10, the decimal point moves the corresponding number of places to the right, as the power itself. If a decimal number is multiplied by 100, which is 10 squared, the decimal point is moved 2 places to the right. If a decimal number is multiplied by 1000, or 10 cubed, the decimal point is moved 3 places to the right. If a decimal number is multiplied by 10,000, or 10 to the 4, the decimal point is moved 4 places to the right. Whenever dividing decimals by a power of 10, the decimal point moves the corresponding number of places to the left as the power itself. If a decimal number is divided by 100, or multiplied by 10 to the minus 2, the decimal point is moved 2 places to the left. If a decimal number is divided by 1000, or multiplied by 10 to the minus 3, the decimal point is moved 3 places to the left. If a decimal number is divided by 10,000, or multiplied by 10 to the minus 4, the decimal point is moved 4 places to the left. 4.5 times 10 to the 3 is a decimal number in standard index form, since there is only one non-zero digit to the left of the decimal point. To expand this decimal number, we move the decimal point 3 places to the right, because we are multiplying by 1000. To expand 14.137 times 10 squared, we move the decimal point 2 places to the right, because we are multiplying by 100. To express a number in standard index form, the decimal point needs to be in what is called standard position, which is the place in the decimal number where there is only one non-zero digit to the left of the decimal point. In this example, the decimal point lies to the right of the last digit, 9. To be in standard position, we need to move the decimal point 6 places to the left. We therefore divide the number by 10 to the 6. However, we cannot change the value of the number in any way, so we must also, at the same time, multiply by 10 to the 6. Multiplying the number by 10 to the 6, and then dividing by 10 to the 6, is the same as multiplying the number by 1, which leaves the value of the number unchanged. So, this number, in standard index form, is written as 1.45332 times 10 to the 6. To express 715 billion in standard index form, the decimal point needs to move from its current position to standard position, and therefore we need to divide the number by 10 to the 11, as there are 11 decimal places between the current position and standard position. And since we divide by 10 to the 11, we must also multiply by 10 to the 11, so as not to change the value of the number. Therefore, 715 billion in standard index form is written as 7.15 times 10 to the 11. To express 0.00123 in standard index form, we need to move the decimal point from its current position to standard position. Standard position is 3 decimal places to the right, so we multiply 0.00123 by 10 to the 3, but in doing so, we must also divide by 10 to the 3, so that we don't change the value of the number. 0.00123 in standard index form is therefore written as 1.23 times 10 to the minus 3. Note that division by 10 to the 3 is the same as multiplication by 10 to the minus 3. This is the fourth law of exponents. If you are unsure about anything we have just done, or just want to refresh your memory, these are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. When it comes to adding or subtracting decimal numbers in scientific notation, the power of 10 must always be the same. For example, to add 3.6 times 10 to the 6 and 5.2 times 10 to the 5, we must either have both numbers expressed to the power of 5, or both expressed to the power of 6. So, we will express 3.6 times 10 to the 6 as a power of 5. To do this, we need to divide the number by 10, but in doing so, we also need to multiply by 10, so that we don't change the value of the number. So, 10 to the 6 divided by 10 equals 10 to the 5. And 3.6 times 10 equals 36. 3.6 times 10 to the 6 therefore equals 36 times 10 to the 5. And now that the powers of 10 for the two numbers are the same, we can add the numbers. So, we add 36 and 5.2, which equals 41.2, and then multiply by 10 to the 5. This answer isn't in standard index form though, so we now move the decimal point one place to the left to get it into standard position. Doing so means we divide by 10, so we now also multiply by 10, so that we don't change the value of the number. 41.2 times 10 to the 5, in standard index form, equals 4.12 times 10 to the 6. Of course, we could have also expressed 5.2 times 10 to the 5, as a power of 10 to the 6, by first multiplying the number by 10, and then dividing by 10. 10 to the 5 times 10 equals 10 to the 6, and 5.2 divided by 10 equals 0.52. 5.2 times 10 to the 5, therefore equals 0.52 times 10 to the 6. We can now add 3.6 times 10 to the 6 and 0.52 times 10 to the 6, to get 4.12 times 10 to the 6. When it comes to the multiplication of decimal numbers in scientific notation, we multiply the numbers first, and then multiply the powers of 10. To multiply the numbers without using a calculator, you will need to do long multiplication. And when multiplying the powers of 10, you will apply the first law of exponents. So, to multiply 1.3 times 10 to the 5, and 3.6 times 10 to the 4, we first multiply 1.3 and 3.6 using long multiplication, and then we multiply the powers of 10 by applying the first law of exponents. The final answer is then expressed in standard index form. Similarly, when dividing decimal numbers in scientific notation, we first use long division to divide the numbers, and then apply the second law of exponents to divide the powers of 10. If you liked this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.